Hello, dear viewers. I am Dr. Shikha. I am working as assistant professor at ABES Engineering College, Ghaziabad in the Department of Applied Science and Humanity. Today, I am going to deliver a lecture on galvanic cell and SHE. SHE is a standard hydrogen electrode. So, before discussing about galvanic cell, let us discuss some basic concept of electrochemistry. Oxidation is basically loss of electron, addition of oxygen, and increase in the oxidation number of a metal. And reduction is the term which is used for the removal of oxygen, addition of electron, and decrease in the oxidation number of element. So, we will discuss with the example. Like if we have a metal, it have the oxidation number 0, and after losing the electron, its oxidation number is going to increase, means is it going to convert positive. And if a metal we have metal B, it have oxidation number 0, and after gaining the electron, it is converting to minus, means it is going to decrease. Therefore, this metal is going to reduce. Now, the term electrode. Electrode is basically, and it is any solid surface on which oxidation and reactions take place. Electrode are two types: anode electrode and cathode electrode. Anode electrode is the electrode at which oxidation reaction take place, and cathode electrode is a electrode on which reduction reaction take place. Now, what is electrode potential? Electrode potential is basically the potential arise between the electrode and electrolyte solution. Suppose we have a copper sulfate solution and it is deep into the suppose we have a copper electrode and it is dipped into the copper sulfate solution. So the potential arise between the electrode and electrolyte would known as the electrode potential. This electrode potential depend upon the nature of the metal, and it is of two type: oxidation potential and reduction potential. Oxidation potential means metal when lose the electron and the potential arise will known as the oxidation potential, and it is represented as electrode potential. Zinc, suppose zinc metal losing 2 electron, so the potential is known as oxidation potential. Reduction potential is the potential arise after gaining of the electron, means zinc having 2 positive charge, and if it accept 2 electron, it will convert into zinc, and the potential will arise known as reduction potential. Now, what is E cell or EMF? EMF, yeah, electromotive force. It is basically the difference in the electrode potential of cathode and anode, and it is represented as E cell, E reduction potential of cathode minus E reduction potential of anode. When we are discussing about the reduction potential, by default, we are talking about the reduction potential, not the oxidation potential. So the E cell can also be represented as E cathode minus E anode. Also, we can represent E cell is equal to E right minus E left, because cathode electrode is present on the right side and anode electrode is present on the left side. Now, what is standard electrode potential? Standard electrode potential is the potential difference arise between the electrode and electrolyte when we use standard condition, means a solution is of 1 molarity and the temperature is room temperature. Also, the pressure is 1 atmosphere. Now, how we represent the standard electrode potential? Standard electrode potential is represented as E naught cell equal to reduction potential of cathode minus reduction potential of anode. Also, it can be represented as E naught cell is equal to E naught cathode minus E naught anode. Now, we will discuss about the galvanic cell. A galvanic cell, basically, it is the example of a Daniell cell. It is also known as voltaic cell after the name of the scientist. Basically, the galvanic cell is made up of the two half cell. And in which one half cell contains zinc sulfate solution and zinc electrode is dipped into the zinc sulfate solution, and the another half cell contains zinc electrode which is dipped into the copper electrode which is dipped into the copper sulfate solution. So what happen here? Zinc, as we know, it have tendency to lose the electron because it is a electron rich metal having d10 electron configuration. So it lose the electron and zinc convert into the zinc positive 2 and come to the solution. So here the electron which is releasing move from anode to the cathode side. Here we have copper sulfate solution, copper sulfate in which copper is the +2 charge. So this copper, the electron which is come from the anode side will accept this electron and will convert into the copper and will deposit at copper electrode. So the electron flow will continue from anode to the cathode. So basically here chemical energy is converted into the electrical energy. But after some time, what will happen? The concentration of the ion between these two half cell will be the disrupt, because as the zinc is converted to zinc positive, so the concentration of the zinc positive ion is increased on the anode side, whereas on the cathode side, sulfate ion concentration is increasing because the Cu2 is converted to Cu and it is going to deposit on the copper electrode. Therefore, at this situation, the flow of the electron will be the hampered due to the disruption of this concentration. So, for this, we use the salt bridge, which is a U-shape glass tube, and in this KCl is filled. What is the role of this KCl? This KCl basically maintain the electrical neutrality, because this KCl dissociate and the positive K positive ion will move towards the cathode and will react with the sulfate and form potassium sulfate. And on the left side, the Cl ion will move towards the anode side and will react with the zinc and form zinc chloride. Therefore, again, the flow of the electron will start from the anode to the cathode. So this is the basic principle of this galvanic cell, or working principle of this galvanic cell. Now, how we can represent the cell? As we know, on the anode side, zinc is going to oxidize and form zinc +2. And on the cathode side, Cu +2 is accepting 2 electron and are converting to Cu. So the overall reaction would be zinc plus Cu +2 is equal to zinc +2 plus Cu. Now, how we can represent the cell? Cell can be represented, as we know zinc is going to oxidize, so it will write on the left side. And copper is deep in the copper sulfate solution and it is going to reduce, therefore it will be right on the right side. Also, we can represent this half cell as zinc +2, a double line Cu, single line Cu. So these zinc is going to convert zinc to, means it is going to oxidize, and Cu is accepting 2 electron, so it is going to reduce. Therefore, it will be right on the right side. Now, here, because oxidation and reduction both are taking place, therefore, this is the example of the redox process. Now, as we have discussed earlier also, the salt breeze make the electrical neutrality of the solution and complete the circuit, so that flow of the electron is continuous from anode to the cathode and generation of the electricity take place. Cell, full cell as can be represented as zinc solid, means a zinc electrode, a single line zinc sulfate electrolyte solution, double line which represent the presence of salt bridge, copper sulfate electrolyte solution and copper metal. And as zinc is converted to zinc positive and Cu as Cu2. So here single line represent different phase and double line represent the salt breeze. Now the question is, if we have half cell, how we can calculate it electrode potential? For that, we use a reference electrode, which is known as standard hydrogen electrode. And the property of this hydrogen electrode potential is that its electrode potential is zero at every temperature. So now we will discuss the construction of this hydrogen electrode. This hydrogen electrode is basically we take the glass tube in which platinum electrode is kept, and the platinum electrode have the property it is an inert electrode and it absorb the hydrogen on its surface. And now it is kept in the acidic solution. More specifically, it is basically the 1 molar HCl solution. So what happen? Hydrogen gas is passed with the help of the silt to this, and it will absorb on the platinum electrode, and the excess hydrogen will come out in the form of S positive ion. So after some time, a situation arises when the H ion concentration and H2 concentration are on the equilibrium situation. So here, both oxidation and reduction reaction take place simultaneously. Now we will discuss how with the help of a standard hydrogen electrode, we can calculate the electrode potential of the half cell. This is the example of a cell in which cell is completed with the help of the hydrogen electrode. So here in one half cell, zinc electrode is deep, and on the other half cell, hydrogen electrode is deep. So because a zinc is electron rich species, so here oxidation reaction will take place and the flow of the electron will take place from anode to cathode, because we know that SHE can work as cathode electrode as well as anode electrode. So here it will work as cathode electrode, and the electron which is coming from anode will accept by the H ion and convert to H2. And the salt bridge will, as we know, its work to maintain the electric neutrality. So it will have to maintain the electron neutrality as well. It will complete the circuit. So this is the representation of this cell. Zinc is converted to zinc positive and it is on the anode. So it will be right on the left side, and H positive is going to convert to H2 platinum electrode. It will write on the cathode. Similarly, we can use this hydrogen electrode on the anode side. Suppose we have the copper electrode. So we know the copper have ability to accept the electron because it is an electron deficient species. So in this case, the hydrogen electrode will work as on the anode side, and here the oxidation will take place. So with the help of the voltammetry, we can calculate the value of the this complete cell, because we know in both of the condition, oxidation as well as reduction, the electrode potential value of the hydrogen is always zero. These are the references. That's all from my side. Thank you.